My name is Sid Deha. I'm the Regional Technical Manager for Leviat Southeast Asia, and today I'll be presenting our MOMENT MPS-T Precast Shoe, the next generation. Today's contents, I'll first go through a quick introduction of our company, Leviat. Then I'll dive into more of the product of the MPS-T Precast Shoe, and then talk a little bit more about hybrid technology, a new innovative way of how to use that. And then we'll have some question and answer sessions at the end. Okay. So to talk about Leviat, I have to talk about CRH, which is our parent company. And they're one of the leading global diversified building materials company in the world. They're number one in North America and Europe, and they're a Fortune 500 company with over 73,000 employees in 29 countries. They have two main sections, their materials division and their products division. Under the products division comes the construction accessories, which is now being formed, is fully formed by Leviat. So Leviat was launched on November 9, 2020, and it unites the expertise, skills, and resources of CRH's construction accessories companies into one single global organization. So together, we are now around 3,000 employees in 60 locations. We sell in over 30 countries. We have manufacturing in 4 continents, and we form 10 trusted brands. So previously, we had 10 separate companies under CRH, under their construction accessories division, and then we had combined them all to create Leviat into one organization. So you may be familiar with our previous company, Half and Moment, which was the main business in this region. But we have now, although we've changed our name to Leviat, our products are still coming under our previous company name. So now product brands as opposed to a company name. So the two dominant ones in this region you may be familiar with is Moment and Halfen. However, Ancon is also being introduced into this region right now. So while we are a new company, only 2 years old, we have quite a vast history. You can see our oldest company, Ancon, has been around for over 140 years. Halfen, our next most mature, being 92 years. And Moment, the company starting off in Asia, in Malaysia and Singapore, over 30 years. So combined, we still have quite a vast level of experience. We supply in all construction sectors, from residential to infrastructure and industrial projects. And we help turn architectural visions into reality, and we look at high-rise structures as well as bridges and transport. Some project references in this part of the world. One that we're right next to right now is the Marina Bay Sands, as well as the Tang Yong Bakar Center in Singapore and Changi Airport as being our most notorious, as well as some key projects in Malaysia. In Asia, we have 5 offices, Malaysia being our main headquarters for Southeast Asia, but a solid standing in Singapore, as well as a presence in China, India, and Philippines. Okay. Now, I'll get into the bulk of the presentation, which is a new product which was released this year called the MOMENT MPS-T Precast Shoe. The MPS-T Precast Shoe is a convenient way to connect precast columns. It provides a dry connection, allowing it to be immediately load-bearing, so that it can transfer loads instantly, including the temporary loading, removing the need for bracing. It's available in 5 load classes, going from size M16 up until M39, and it has a range of anchor bolts and accessories to tailor for different situations. So how it works, so the precast shoe, being the main body of the system, is installed into the column into the factory. On site, the anchor bolts are installed into the foundation. However, for column-to-column applications, the anchor bolts will then just be installed in the precast column in the factory also. And then once all the concrete's poured and it's delivered to site, the column is simply lowered over the anchor bolts and then tightened in position with the high-strength nuts and bolts, and being immediately effective, allowing the crane to be disconnected and used elsewhere. Grouting is needed more for durability to protect the steel. However, because it's not relevant to the structural performance, it can be done at a later stage that's more convenient. So the precast shoe consists of five separate components. The first two, the precast shoe and the anchor bolt, are the main components, while the remainder, positioning bolt, the recess formers, and the end cap are accessories to facilitate installation. Now the precast shoe consists of four pieces. The base plate, which is the ductile cast iron body at the bottom, two tension bars and one compression bar. The tension bars being the long rebars at the front, and the compression bar being the one at the back. And as I mentioned before, there's 5 load classes available from 16 to 39, giving you a design tension value from 61 kilonewtons to 383 kilonewtons, giving the flexibility to accommodate a range of different design conditions. Okay. Zooming in on the base plate, as I mentioned before, it's formed from a single piece of cast iron steel. It has some threaded sections to facilitate the tension and compression bars to be screwed in. And it's been optimized for both for stiffness and for bending resistance to make sure that at the serviceability limit state there is not much deflection, but at the ultimate capacity it can take the full capacity of the anchor bolt. At the rear, it's been tapered down just to save as much as material as possible and try and making it as the most cost effective, or quite cost effective. So the profile contains those 3 threaded holes, and which are also sort of extruded at the top to allow for a larger thread length for a better connection with the reinforcing bars. The design also includes a guide plate at the front, just a thin piece of steel, just so that it can be positioned hard up against the formwork for easy installation. Now, with the anchor bolt, quite simply, it's a standard reinforcing bar that's available in the market. That we have a rolled thread at the front, just with the standard metric threads. And we utilize high-strength nuts and specialized custom washers to facilitate the oversized hole in the base plate. So the anchor bolts are rolled to ensure, in terms of the threading, it is a rolled thread process to ensure that the full tensile capacity of the thread can be achieved. The positioning bolt is a compulsory accessory. It's also reusable. And it's purely designed to facilitate the installation of the base plate onto the formwork. And so it consists of the steel section there, which will go through the base plate, and then we have the nut and wing washer, which will then clamp the precast shoe onto the formwork, giving it an accurate level of installation. The recess former is also a compulsory accessory. It is one-time use, and it basically just creates a void just above the precast shoe, or just above the hole, to facilitate the anchor bolt coming through and being able to fix the nut and washer. 2 versions are available, one specifically for a corner, which is the most common use, so the corner of the column, but we also have the edge recess former, if the column shoe needs to be also positioned in the center of the column. And this one, the end cap is a recommended accessory. It's not compulsory. It is also reusable, so we do heavily recommend it. And it's simply just a cap that fits over the top of the thread to protect it from damage during installation of the column. You don't need many of these. It's basically just enough for to cover one column, because you can then reuse it on the adjacent columns as you install more. Now, just going a bit more into the development of the product. So this does the precast shoe, or our previous product, the column shoe, does already exist. It's been around for quite some time, and it's been quite loved and successful. However, we wanted something that was a bit more versatile, a bit easier to install, and a bit easier to store and transport. And so that's why we came up with the detachable base plate. The previous design is completely welded, making it difficult making it quite bulky. So we started off just developing a calculation model in Excel, using first principle engineering, going through calculating all the stresses and determining the approximate thicknesses needed for the item. We then used that mechanical model to prepare a prototype, just a very basic prototype, just to confirm the model, which we then tested to destruction, verifying that design. From there, we went to final element analysis, modeling the entire thing, and reiterating the design to optimize it to save as much as material as possible. We also compared the results of the FEM to the prototype sample that we had developed to be able to tweak the design or tweak the settings of the FEM model to make sure it matches up exactly. After that, once we had the final design in mind, we then proceeded with final prototype molds, got them ordered, and did mass testing to destruction. And the advantage of the new design is that the load transfer or the internal load transfer is all via the tension and compression bars. The previous column shoe did require the column linkages to restrain the eccentricity. Sorry, just a bit of noise. Yeah. So the previous column shoe required the use of column linkages to restrain the eccentricity of the anchor bolt. However, with the upgraded version, that is no longer needed. And so the full design can actually the full capacity can be tested and realized in air without the need of concrete, which is what we did during our R&D stage. Okay, just a quick video on the installation. Okay, so this is the base plate and the bolts connecting it to the formwork, followed by the recess formers. You see the reinforcement being placed in, and a cast-in bore pipe to make it easier for grouting. However, it's not needed, but it's highly recommended. Now, on site, the anchor bolts also have to be installed using a template. We do have installation tolerance in the system. However, you still need to be careful and pre-plan the installation of the anchor bolts. As you could see in the illustration, the end cap there. Now the bolts being installed and tightened. And then finally, the grouting is done just to hide the connection and give us some durability protection. However, the grout is not needed for the load transfer. Okay. There's also some additional applications where it can be used. So generally, it is used for column-to-column connections or column-to-foundation connections. However, with the use of some special anchor bolts, utilizing our reinforcing bar coupler systems, we can utilize the same precast shoe for beam to column connections. And what I've shown here on the screen is just sort of a concept of how we can use the fact that the dry connections are immediately load bearing to allow us to actually move the location of the connection so that it can be joined at a place or closer to the point of inflection, so that the bending stresses are reduced, allowing even further optimized designs. If you were to do the connection traditionally right at the beam to column joint, the bending stresses would be quite high, and then the requirements for the actual precast shoe would increase significantly. So by giving this option, we're able to reduce the amount of items that you do need to give a better design. What I've shown here is in terms of a T section. Yeah, that doesn't need to be that way. This is just a concept. It can also be done flat, right at the top, with some additional details, so that all the items will be poured two-dimensionally, basically, which will make it easier for transportation and also in the precast yard. It can also be used for water wall connections using the customized anchor bolt also. The reason we need a customized anchor bolt is that you can't have the threaded section protruding from the wall, as well as the beam to column section, because it would clash with the adjacent precast member. So what we will do would normally put a rebar coupler at the end with a high strength threaded rod that will then screw in. But it's a good alternative to what's currently being used, which is weld plates and all the loop boxes, which are wet connections or connections that are not immediately load bearing, so that there'll be additional propping that's required, and particularly in the case of welding, there's a lot of additional hassle on site, as well as could be some safety concerns with on-site welding. A special recess form is also required for this condition because to allow access from the side. So minor detail, but it's just one to keep in mind. So in terms of the summary of the benefits, so in terms of the person using or installing the precast shoe, it is definitely much easier to install and handle. So with the previous versions, the column shoes, as I mentioned before, it comes completely assembled and welded, and the larger size could weigh 30-40 kilos, making it very difficult for one person to install. And so they would generally require the use of the crane in the precast factory, making it a little bit troublesome and resource intensive. With a new design, because the base plate can be detached and it's fairly lightweight, it can be installed with just one person without the use of a crane or anything. And then the rebars the tension and compression bars can be screwed in after the base plate is fixed into position, significantly increasing the productivity at the precast yard. In terms of the designer, it's the same sort of benefits that we had with our previous column shoe in terms of the range of the range of sizes and the accessories. However, the new load transfer mechanism means it can be used for other applications, particularly the beam to column and the wall to wall, as I mentioned previously. We also have quite a dedicated design team both in Singapore and in Malaysia, providing sort of non-obligation design services for your precast connections. So you're able to contact us directly at technical.asia@leviat.com, or you can see us in the booth after this, and we can provide more information there. In terms of the buyer, the new design is making it more cost efficient, much easier for transportation and particularly storage, because it can be much more condensed than the previous version. Now, the next thing I'd like to talk about is the hybrid technology. Basically, is there another way that you can connect precast columns? So right now we have the precast shoe, which I just mentioned. But another product that we do have is the grout coupler, which is also a cast iron sleeve that is pumped with grout to create a connection between the rebar and the two rebars together. It also provides similar installation tolerance to the precast shoe. However, the main point of difference is that it is a wet connection, so it requires the grout to cure before it can be load bearing. So with the hybrid technology, we use the two of them together to give us the best of both worlds. So the grout coupler is a much sleeker system, and it can provide direct continuity of your reinforcement through the construction joint or the precast joint. But because it is a wet connection, it would require propping of the column. But when used in combination with the precast shoe would use basically the bare minimum, which is just one in each corner, just enough to resist the temporary loading, and also giving you the ability to adjust the column without the need of the crane. And then when you do then grout the connection at a later date, you get basically your full moment continuity of your column, continuing all the reinforcement through the joint, but at a cost-effective and convenient price. So this is just a close-up of a project that we had done in Singapore. So you can see the column shoes in each of the corners, and in between we've put in all the grout couplers to create the higher capacity. We've also worked with our contractor to develop what we're calling mass grouting, and with that we introduce additional grouting holes into the column itself to allow all the grout couplers and the area around the precast shoe to be grouted all at once, significantly reducing the time it takes to grout the section, making it an even more efficient solution. Okay, so this is just a photo of what's on site. So as you can see, you have the anchor bolts in each corner with the grout for the connection with the precast shoe. You have the nut and bolt on the bottom, which is what the column will initially sit on. For larger columns, we would also recommend a shim in the middle, but depending on the weight, it's not always needed. And then once the column is lowered, another nut and bolt would go on top, clamping it together. The reason we have the nuts on the bottom also is two reasons. One, to make it both a tension and compression a load transfer mechanism, but also give the ability to be able to be adjusted without the need of the crane. And that's the most beneficial, to be honest, because it can reduce the installation time from 1 hour using the traditional methods like a PT duct or whatever, down to 15 minutes. So that saving in crane time is quite valuable, and this is why it's becoming more and more common to use this method. We also can see the protection cap on the top protecting the threads. That's not needed for the grout coupler because there's no threads to be protected. Okay. This is just more examples on site. So this is lifting the column into position on the left side here, and you can see the column that's already been installed. You notice that there is no bracing. It can be freestanding, and it also in this photo had not yet been grouted, but it's getting prepared for grouting. And so once it's in position, it can be leveled or adjusted without the need of the crane, which is one of the most valuable assets of this system, leading to that significant reduction in time, almost a quarter of the time taken, or a quarter of the crane time taken for this sort of installation. This is a close-up view of the hybrid solution. So the precast shoe in the corners again, with the grout holes for the grout coupler. Now, during mass grouting, we would close up the entire joint, concealing it completely, and then we would pump a grout into the grout hose that's been pre-installed, and that would flow down into the bottom of underneath the column, and it would fill in, and the air would then escape via the grout holes the holes in the grout coupler. And as the grout starts flowing through the grout couplers, we will then plug each one individually, ensuring that each one is fully filled. Okay. This is just another photo of the grouting process. You can see there's no special equipment really needed apart from a small manual hand pump. You can use higher, electric ones, but the handheld one is sort of just a bit, it does the job, and it's also safer to ensure that the grouting process is not interrupted once it's started. And there is no pressure requirement in terms of for pumping the grout, because you'd freely see the grout flowing once it's all filled, confirming that everything is full. Okay, it's just once the grouting is completed, we can see the grout had flown out of the vent holes, or the air vent holes, which have then been plugged, and also the grout hose also being tied off. Okay. This is just another example of where the dry connection is quite important or quite beneficial, and that's the use of connecting double columns. So it's even harder to brace the top connection of the column. And this particular project, it was seen a lot more cost effective to break the column into two, allowing a smaller crane to actually be used instead of having getting a higher load rating crane. We're able to cut it into two, and even with the additional connection, still provide a cost saving just from the smaller lease of the crane. Okay, that is all. Thank you for your time, and if you have any questions, I'm happy to take some.
Thank you so much, Sid.
Thank you. Okay, so what is the minimum wall thickness for the wall connection? I believe with the smaller size, we can get around 150 thick wall. The MPS-T 16 can fit into that. Is the precast shoe seismic tested? Not yet. We do believe it will meet seismic requirements, and we are looking into that now. However, one option that we can look at is the hybrid solution for seismic resistance. If we can actually just use the column shoes purely just for the temporary loads, and then design the permanent connections using the grout couplers only. And the grout couplers have been seismic tested and can give you that confidence needed. And then the last one, could there be a risk of thread stripping of the rebars of the precast shoe? No, so that's why we have gone towards a rolled connection to give it the fully formed threads, which will be able to give the full capacity of that threaded region.